Alright guys, I am not feeling well, pretty much sick as a dog, so in case you guys have trouble with your covalent bonding Lewis dot structures, I figured I'd give you some help today, and that way if you have problems during class tomorrow you could just watch the video as a little remediation session. So on my periodic table here I have my groups 1A through 8A labeled. If you remember, electronegativity decreases going from right to left, and it also decreases from top going down. So just to kind of relate that to what we're doing now, if you have two different elements in your covalent molecule, we want to have the least electronegative one in the middle. So I'm going to do 4 examples with you today, and our first one is going to be NH3. So first thing to do is let's calculate our total number of valence electrons. And for N we have 1 atom, and each one of those, if we look at our periodic table, N is right here, it's in 5A, each one of those is going to have 5 valence electrons. 1 times 5 is 5. For H we have 3 atoms. Each one of our H's, if we go back to our periodic table, it's in 1A. Each one of them has 1 valence electrons, and that's going to be 3. If we add those together, 5 plus 3 is 8. So that's just going to tell us our first part with how many electrons we can put in. Now, the one exception to our electronegativity rule is hydrogen. Hydrogen is never ever going to be in the middle. Reason being is because hydrogen can only have 2 valence electrons around it, since it only has 1 energy shell. So we're going to put our N in the middle, and I have 3 hydrogens to put in. So I'm going to make our bonds. There's 1 hydrogen, another hydrogen, and our last hydrogen. And if you remember guys, each one of our lines counts as 2 valence electrons. So right now I put in 1, 2, 3, 4, 5, 6 electrons, and I have 2 left to put in. Now if we look at our diagram, each one of our H's, and I'm just going to circle them, I know this isn't going to look great for you guys, but each one of our H's has 2 valence electrons surrounding it. So those are all good. We can't put any more valence electrons around hydrogen. The only place for our last 2 to go are going to be right here around nitrogen. Alright, and that is our answer for NH3. So if we look at our middle one, it has 2 lone pairs. Or I'm sorry, 2 lone electrons. Okay? So for our second one, I wanted to do SO3. Now if we look at this one, we have S and we have O. If we look at our periodic table, S is underneath O, and remember as we go down our electronegativity decreases, so we know that S is going to be in the middle. So how many S's do we have? We have 1. It's in group 6A along with oxygen, so both of our elements are going to have 6 valence electrons. We have 3 oxygens, and 3 times 6 is 18. When we add both of these together, we get 24. Now, we're going to put S in the middle as we already talked about, and I'm going to connect my 3 oxygens. There's 1, there's 2, and there's 3. So right now I use 1, 2, 3, 4, 5, 6 electrons, giving me 18 more to put in. Now what I like to do is I like to start on the outside and start filling them in so that they obey the octet rule, all of our oxygens first, meaning that they have 8 electrons surrounding them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. And I just use all of my 18 electrons. That means I have 0 left over. Now, if you look at this, all of our oxygens are going to have 8 around it. 1, 2, 3, 4, 5, 6, and the bonds counts as 2. Same thing with this one, same thing as our top oxygen. All of them are going to have 8 electrons. However, if we look at sulfur in the middle, we have 3 bonds coming out of it, meaning we have 1, 2, 3, 4, 5, 6 electrons. So that does not right now obey the octet rule. And I don't have any more electrons to put in because I'm already out. So this is where we're going to change up our bonds a little bit, and we're going to make a double bond on this one. So it doesn't matter which one you guys choose from. You can choose from the left oxygen, the right oxygen, or the top one, but we are going to bring a pair of our electrons in. I'm just going to choose the right one, and I'm going to bring that pair in, and I'm going to create a double bond. Now, since I brought that in, these ones are gone, so let me erase them. Now, if you look at our sulfur in the middle, I now do have 1, 2, 3, 4, 5, 6, 7, 8 valence electrons around it. And my oxygen on the right, I did still keep 8 because I have 1, 2, 3, 4, 5, 6, 7, 8. So that is our final answer, and every single atom in there does obey our octet rule. So that's for SO3. A little bit different than the NH3 one, a little more complicated because we had to put that double bond in, but pretty much still the same concept. A little bit harder of a one. I wanted to do CH3OH for the next one. All right, now we know that carbon is going to be in the middle because if we look at our periodic table, we just get rid of hydrogen. We don't want to worry about that one, but between carbon and oxygen, carbon is more to the left of our periodic table. That means it's more electronegative, so we know the carbon is going to be in the middle. Now, if you notice our H's, this can get a little bit tricky, but it's almost given to us as a useful part of our puzzle because it tells us that our H's for this one is attached to the C, but since the H's are broken up, it tells us that this one over here, they didn't just randomly do it, it tells us this H is going to be attached to our O. So we have one carbon. Carbon has, it's in 4A, it has 4 valence electrons. Hydrogens, we have 3 here, 1 here, so that gives us 4. You know, hydrogen has 1 valence, that's going to be 4. And lastly, we have 1 oxygen. Oxygen has 6 valence electrons, so that equals 6. When we add all of these together, we are going to get 14. So let's start making our diagram. We're going to have our carbon in our middle, and we are going to have 3 H's attached to our carbon. There's 1, there's 2, and there is 3. So I used 1, 2, 3, 4, 5, 6 electrons right there. I have 8 more to put in. Now, for our next part here, we know that the hydrogen is not going to be attached to our carbon because it would just said CH4. So we know it's going to be our oxygen instead. We're going to attach the oxygen to there, and I just used another 2 electrons, so I have 6 left over. Now we're going to bond our next H to the O because there's really nowhere else to bond it. So there's another 2 electrons. I have 4 left over. The only place I can put my last 2 electrons, because carbon has 1, 2, 3, 4, 5, 6, 7, 8 around it. All of our hydrogens have 2, so they're all good. But the oxygen only has 4, so let's put those last 4 around it. And there you go. So that's our final diagram. Everything matches or obeys the octet rule where we have 8 around our oxygen, 2 around each hydrogen, and of course 8 around our carbon. Alright. Last one, guys. So this one, just kind of adding some rules in here. We're going to do nitrate, which is NO3 with a 1 negative charge. And if we look on our periodic table, N is 1 step over from oxygen to the left, so N is going to be in our middle. And it also has 5 valence electrons. It is in 5A. So 1 times 5 is 5. Our oxygen is 3. Oxygen is in 6A. So we're going to have 18. Now, last thing you guys got to do is worry about this little guy right here, that little charge. So that says 1 negative. whatever that charge is, we are going to do the opposite of it. So if it's 1 negative, what we're going to do is we are going to add 1 electron to it. If it's at 2 negative, we would be adding 2 electrons to it. So for this one, we're going to add 1. So it's 5 plus 18 plus 1, and that's going to give us 24 altogether. So now N's going to be in the middle. We're going to have our 3 O's attached to it, just like that. So I used 1, 2, 3, 4, 5, 6 right there, and I have 18 more to put in. So again, guys, I like to start on the outside and work my way in. So I'm going to start around the oxygens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So I have 0 left to put in. And this is a lot like our SO3 example, but there's going to be one difference in the end. So what I'm going to do, if you notice here, my oxygens are all good. My nitrogen is not. I have 1, 2, 3, 4, 5, 6 electrons around nitrogen. Does not obey the octet rule. So I'm going to move 1 pair of electrons to create a double bond right there. I'm going to erase this pair of electrons because I moved them to the middle. And we are all done. Except for one thing. If someone were just reading this as it is, it looks like we just added a random electron in there. Because of that 1 negative charge, this does not say we have a 1 negative charge on it. So it says there's a random electron that I just kind of stuck in my diagram. So the last thing we have to do, guys, on these ones is, since it has that 1 negative charge, we are going to put brackets around our whole molecule. And then on the outside, in the top right-hand corner, we are going to put our charge. And that charge tells us, hey, we didn't make a mistake. We have an electron added in there because there is a charge on the whole molecule. All right, so that's pretty much all you guys are going to be doing today. Hopefully this helped a little bit since I'm not there, just trying to give you guys some more resources. That way you're not completely lost. I will see you guys tomorrow, and you have a good rest of your day.